So we have this compound CHO that's going through the combustion reaction, and it's yielding 9 grams of CO2 and 2 grams of H2O from only 4 gram sample. So we're essentially going to try to figure out the empirical formula of the CHO based off of this information. So one thing we can do is realize that grams can be converted into moles really easily by using molar mass. So we can take the molar mass of CO2, which equals 44.009 grams per mole. And we know that if we have 1 mole of CO2, then we're going to have 1 mole of C, and we're going to have 2 moles of O. And so that's why if we convert this to, instead of having grams of CO2, and if we have moles of CO2, we'll just know immediately how many moles of C we'll get. So let's do that. We have the grams on top, the moles on the bottom. We're going to divide, we're going to take our 9.42 grams of CO2, and then we're going to multiply that by the 44.009, and then we're going to have the moles on top. So let's see what that what happens there. 9.42 divided by 44. And so we essentially just get a 0.214 for the ratio there, and this is going to be moles of CO2. And that means that we have 0.214 mole of C. We also have like 0.4 moles of O, but let's not worry about that. So now we can take a look at the next compound, which is H2O. So H2O, if we want the molar mass of that, that should be 18.015 grams per mole. And again, if we have 1 mole of H2O, then we're going to have 2 moles of H and 1 mole of O. So let's see what happens when we do this calculation. We're going to take the 2.57 grams of H2O. We're going to multiply that by the 18.015 grams. And get the moles up there. And we will get 2.57 divided by 18.015. Makes 0.143 moles of H2O. Now remember, we kind of have to multiply this number by 2 to figure out how many moles of H we have. So we technically have 0.285 moles of H. So now we have the moles of C, the moles of H. Well, that's pretty cool. Now what I did from here is I converted the moles of C and the moles of H back into grams. So let's see how many moles of C, or how many grams of C that is. So we take 2.214 times, periodic table says that carbon has 12.011. So this would be 2.57 grams of C. And for the H, it would be more like 2.85, something like that, times 1.008. So we're left with 0.287 grams of H. So now let's go ahead and add those two numbers up. 2.57. This gives us how many grams we've used up so far, because we started with 4 grams and we've used up 2.857 grams. So that leaves us with 1.143 grams of O. And if we convert that into moles, let's just go ahead and divide that by the molar mass that we have here for O, just 15.999. So we get 0.0714 moles of O. Now we can go back and divide all of our moles, so the moles of C, the moles of H, and the moles of O, by the least number that we have here, which is this one. This is the smallest number, so let's divide everything by that. We divide this by that, we're going to get 1 mole of O. So for every 1 mole of O, we get 1 mole of O. For every 1 mole of O, let's divide it by the H divided, 2.8 divided by 0.0714, gives us 3.99, that's 4 moles of H. And then we're also going to divide it by that. 0.214 divided by 0.0714 gives us 3 moles of C. And with this information, we've discovered the empirical formula. So we'll be able to say C, we have 3 of those. H, there are 4, and O, there's just 1. So we have our empirical formula.